All right, so this is activity 7.4. It's not a race. Elena's family is driving on the freeway at 55 miles per hour. Andre's family is driving on the same freeway, but not at a constant speed. The table shows how far Andre's family has traveled, D in miles every minute for 10 minutes, and T would be minutes. All right, so let's look at Elena. So all we know is that her family is traveling at 55 miles per hour. Okay? So we're going to go ahead and assume that that's a constant speed because they point out to us that Andre's speed is not constant. So 55 miles per hour. And then for Andre, we have a table. So we basically have an input-output table. So T would be our input, which again is our independent variable. Which is our x, and d distance in miles would be, excuse me, our output, which is our dependent variable, and our y. So remember, so two ways you can think about this. So you can think the equation of a line, which is y equals mx plus b. But if we're talking about a constant speed, right, something that's proportional, we actually won't have b because b would be 0. So it would be mx plus 0, so we can just get rid of that. Or you can think about it as the equation of a function, which is going to be the output, right, the dependent variable, is equal to the rule. So the output, the dependent variable, in our case, would be d, right? Distance. So some of the amount of miles traveled would be equal to the rule, and all we know about the rule is that we're traveling 55 miles per hour. So the rule would also need to contain the independent variable. So it's the same thing. D equals 55t. You can think about it as y equals 55x, right? Miles per hour would be our x, and the 55 would be our slope. That's our rate of change, 55 miles per hour. So keep that in mind. So number one asks, how many miles per minute is 55 miles per hour? So we need to change miles per hour into miles per minute. So we're going from per hour to per minute. So we have 55 miles, and remember the per is basically a fraction bar or division per 1 hour. We need to change that to minutes. We're going to keep our 55 miles. That's not going to change. How many minutes are in 1 hour? 60 minutes are in 1 hour. So 55 miles per hour is the exact same thing as writing 55 miles for 60 minutes. And remember the fraction bar is also division, so we can just go ahead and put that into our calculators. So 55 miles divided by 60 minutes is a 0.916 repeating, and we're just going to go ahead and round that to 0.92. So 0.92 miles per minute. So to answer the question, how many miles per minute is 55 miles per hour? 0.92 miles per minute. Okay, so we're going to use that, and that's basically our new slope, our new rate of change. So instead of d equals 55t, that's going to change to d equals 0.92t. So the output, the distance traveled, is going to be equal to the rate of change, 0.92 miles per minute, times each minute that we're traveling. Okay? All right, so question 2. Who had traveled further after 5 minutes? And then they want to know after 10 minutes. So I'm going to go ahead and get rid of our notes about the input output, because we know that already. It's like I erased too much. Alright, so alright, so who's traveled further after 5 minutes? So let's look at Elena. After 5 minutes, Elena has traveled, remember she's going 0.92 miles per minute. So after 5 minutes, it would be V equals 0.92, but we know our T, right? T, we're talking about time in minutes. So T is minutes. And we're going to substitute 5 for T. And again, you just put all that into your trusty calculator. 0.92 times 5, you get 4.6. But remember, distance is miles. So let's make sure we answer that question correctly. 4.6 miles in 5 minutes. So I'm going to write that here for number 2. So Elena, I'm just going to write E. 5 minutes travels 4.6 miles. Okay. Let's go ahead, since we're talking about Elena, let's go ahead and see how far she travels in 10 minutes. So you can also just double that. So D equals 0.92, because that's our rate of change. And we're going to multiply that by T, the amount of time, and we're talking about 10 minutes. So again, you can use your calculator, or just remember that when you're multiplying any number times 10, you're going to move the decimal place 1 to the right. So it will be 9.2. And since we're talking about the variable D, we're talking about miles. So then also for Elena, 10 minutes travels 9.2 miles. So in 10 minutes, Elena can travel 9.2 miles. In 5 minutes, Elena travels 4.6 miles. All right, so now let's look at Andre's family in the table. So in 5 minutes, this makes it a little easier. 5 minutes, we see that Andre has traveled 5.1 miles. And in 10 minutes, Andre has traveled 9.1 miles. So who travels further? Let's look at 5 miles. In 5 miles, Andre travels 5.1, and in 5 miles, Elena only travels 4.6. So who travels further? Andre does. So I'm just going to sneak that in here. Andre travels further in 5 minutes. Who travels further in 10 minutes? Andre travels 9.1 miles, and Elena travels 9.2. So Elena travels further in 10 minutes. She travels 0.1 miles further in 10 minutes than Andre. Alright, let's go ahead and look at questions 3. How long did it take Elena's family to travel as far as Andre's family had traveled after 8 minutes? Well, to answer that question, we need to figure out how far Andre's family has traveled in 8 minutes. So let's go ahead and get rid of some stuff. Okay, so how far did Andre's family travel in 8 minutes? Again, we're going to go back to our table. 8 minutes, Andre's family has traveled 7.4 miles. So we want to know how long, so we're looking for time. How long did it take Elena's family to travel as far as Andre's family had traveled? Well, we know what that is, 7.4 miles. So how long did it take Elena's family to travel 7.4 miles? So again, we're going to go back to our equation for Elena's family. And so basically, actually I'm going to write it here in the middle. Okay, so we're solving for t. We want to know t, and we know the distance. We know d. So d is 7.4, and we want to know t. How do we solve this equation for t? 7.4 equals 0.9 t. So we're going to divide each side by the coefficient, which is 0.92, the rate of change. So on the right side, 0.92 divided by 0.92 is 1. So we're left with 1t, but we're just going to write that as t. And on the left side, we have 7.4 divided by 0.92, and we get 8.04 and some change. So we're just going to go ahead and round that to 8.04. And again, t is time, so we're talking about minutes. So to answer the question, how long does it take Elena's family to travel 7.4 miles? It takes them 8.04 minutes. So basically, at about 8 minutes, a little after 8 minutes, Elena's family has traveled 7.4 miles. Alright, so the last question, question 4. For both families, the distance in miles is a function of time in minutes. And remember our function statement. Dependent variable is a function of the independent variable. Output is a function of input. Y is a function of x, right? 3 ways to say the same thing. Compare the output, so we're talking about, in this terminology, we're talking about our d, our distance. So compare the distance for these functions when the input, which is time, is 3. Okay? So for Elena, again, that goes back to our equation. So I'm just going to get rid of this. It goes back to our equation. What's the output? What's d when the input t is 3? So now we're just going to substitute t for 3 and then figure out what the output is. So 3 times 0.92 is 2.76. But again, we're specifically talking about distance, so it's 2.76 miles. So when Elena, for Elena's function, when the input is 3, right there, E, when the input is 3, the output is 2.76, and that's for Elena. Now we just need to go to the table for Andre's family. So let's check out when the input is 3. So when minutes is 3, what's the output? We get 3. So for Andre, when the input is 3, his output is 3.0 miles. So again, just like in the first activity, we can compare different types of functions. It doesn't matter if they give it to us in an equation, a table, a graph, or a description. We can compare functions that are given to us in different models.